Hello everyone, this is Introductory Algebra, September 17th, and I'm recording this video again because during the class Zoom, we had too many disturbances. So this would be chapter 5.9 from the book, which focuses on application of the quadratic equations. Okay, chapter 5.9, let me write it down. Okay. Chapter 5.9 right here. Okay, so we're not going to go through the whole chapter, just two type of problems, and this would be for this chapter. So this is chapter 5.9. Okay, the two types of problems we are going to focus on are problems about consecutive numbers, and the other type would be problems about the Pythagorean theorem. So here is the first problem about consecutive numbers. You can read it. It's arrays and they have numbers assigned to them. The numbers are consecutive integers. Okay. And the product of those numbers was 240. So integers could be positive or negative. In this case, we're looking for positive numbers because these are like both like labels. I've never seen a both negative number, negative 36, for example. So it makes sense that our integers will be positive when we get them. So what does it say? Okay, if you have integer numbers, let's say 36 is an integer, the consecutive integer to 36 is 37, right? So if your integer is x, the consecutive integer will be x plus 1. Okay, so in every problem you're going to, for about consecutive integers, you're going to set your first number to be x and the next one to be x plus 1. So let's see what it says. It says the product of the consecutive integers is 240. This means that x times x plus 1 would equal 240. Okay. So you need to find x. What do you need to find? X, the value of x. So let's say question mark x equals a question mark. So how are you going to find it? You probably recognized already that this is a quadratic equation, because if you distribute the x, you're going to get x squared plus x equals 240. So how do you solve quadratic equations? You solve them by setting the equation equal to 0. To do this, you need to minus the 240. So you're going to have this equation. Okay. The next part, you can use quadratic formula or factoring to solve it. Here, because there is the coefficient in front of the x squared is 1, I can factor it the easy way, which is which two numbers multiply to give you negative 240, okay, and added together give you 1, because the coefficient in front of the x is 1. This means the two numbers are actually consecutive numbers, and they need to be positive and a negative. Since the product of two numbers is negative, this means that one of the number is positive, the other is negative. For now, let's first figure out how we can get to 40 without worrying about a positive or a negative. Okay, what's 240? 6 times, let's say 60 times 4. Okay, well, this doesn't work. If you subtract them, they would not give you 1. Let's say then 30 times 8. What I'm doing, I'm going down, I'm going down from 60. 60 is 2 times 30, right? So if I want to keep the 30, I can multiply the 2 by the 4 and get 8. Okay, the next 30 times 8 doesn't work. So let's see, this is 2 times 15, right? The 30. So what's going to happen? If I want to have 15 here, I'm going to have 2 times 8, which is 16 right here, right? Oh, look, 15 and 16. Those numbers are consecutive. And when I subtract them, I'm going to get 1. So now we got the numbers. Which one is positive? Which one is negative? The one we're having right here is a positive. So this means that the larger number is positive. And the larger number is 16. So the negative would go to 15. So if you want to factor, at this point, honestly, factoring is pointless, but we're going to finish. Okay, so minus 15 plus 16 right here, right? This equals 0. So let's set, how do you solve this? From here, you're going to use the principle of zero product. And this chapter is the last chapter from factoring. So you already, I'm assuming that you know how to factor, right? So we're not going to teach you the basics of factoring right here and solving quadratic equations. So you need to set each one to equal 0, each expression to equal 0, right? And I'm going to erase this here. Oops, shouldn't have erased this, but okay. Think. And I'm speaking fast because I know that you can stop and slow down the video and watch it again. This is what I do when I'm listening to some very cool sermon or some teaching I want to know and learn from. I'll just stop it, go back, listen again until I get it. So I hope that you can do this too. Okay. So once you set those two equals 0, you get x minus 15 equals 0 and x plus 16 equals 0. Okay, or x equals 15 and x equals negative 16. Now, we're looking for integers which are labels on a board. So those are going to be positive. So we are not even going to consider 16. Okay, right. So the first number is going to be 15. And the consecutive integers from 15 is 16. So the two numbers we're looking for are 15 and 16. Okay, let's see how the PowerPoint is going to put this nicely. Okay, it takes a little bit. Okay, here you go. Translate. Here you go. X times x plus 1 is 240. Distribute, subtract, set equal to 0 after factoring. These are the numbers. Cancel the 16. And here you go. Okay, 15 and 16. Okay. If you can, for practice, you can go in the book, and example 4 is the same problem. Now they're marathon runners and their t-shirts are consecutive numbers, and the product instead of 240 is 156. So it's the same problem, just the numbers are different. The number right here is going to be 156, right? So what you need to do, you have to figure out which two numbers multiply to give you 156 and add it together. Considering one is positive, the other is negative, would give you 1. Okay, so I can do this problem, and to Alex, you can see other problems, and they all look the same. Okay, so the next type of problem we are going to do, why is not erasing now? Okay, okay, let's see. The next type of problem is the one everybody knows. When I ask what is a squared plus b squared, even if I mean something else, everybody says c squared. Or if I ask what is a squared minus b squared, everybody says c squared, but definitely this is not what I was looking for. So the Pythagorean theorem says that if you have a right triangle, so it's about the right triangle. If your triangle is not a right triangle, you cannot apply this. So what's a right triangle? A triangle which has a right angle. Here we go. Right angle. The side across the right angle, this one, it's called hypotenuse. Yes, it has its own name. Okay, the other two, who cares? They are both called legs. Doesn't matter which legs is first, second. This is just a leg. Here you go. Leg. Okay. So this is the theorem, says the square of the hypotenuse equals the sum of the square of the two legs. Okay. I hope you know this by now. Okay. But if you don't despair. we can always learn it. So now the problem. This problem might look confusing, so let's just take it step at a time. And to give you hope, most of the problems on Alex would look like that, about ladders and houses. Yeah. So what we have a house, a ladder and a house. This is what we're reading right here. So we have a ladder and we have a house. So let's make our house. Okay. Here. Let's make it like in Bulgaria, apartment building. Oopsie. Well, the windows don't look like that, but let's imagine. Okay. This is apartment building. Got it. There is no, the roof is just a little flat balcony kind of thing. Okay. So this is the house. Let's get a ladder. The ladder will be red. Here is the ladder. So it's leaning. The ladder is doing what? Leaning against the house. So let's, oh, hold on. Let's put the grass so we know where the ground will be. So this is the grass. Here is your grass. Okay. The ladder. So the ladder is like here, leaning. Okay, imagine it's a ladder. I don't want to make it like, you need to draw it two-dimensionally because then it will be too many details. So here is the ladder, the red. You're looking at it sideways. Yeah. So what it says, the ladder is 13 feet long. So this is 13 right here. Okay. What else does it say? Okay. Now let's decode the second sentence and make this a little thinner. Okay. So the second says that, okay, let's what color? Let's say blue. It says, no, let's get orange. Okay. It says the distance from the bottom of the ladder. Okay, this is the bottom of the ladder right here. See the bottom of the ladder. So the distance from the bottom of the ladder to the house. This is the distance from the bottom of the ladder to the house right here. Right. This is what they're talking about. This distance is 7 feet less than the distance from the top of the ladder to the ground. So before we get excited about the 7 less, let's look at, make it blue. Let's see what is the next distance. Okay, 7 feet less than the distance from the top of the ladder, which is right here. See the top of the ladder to the ground. The ground is here. Okay, here you go. So let's now read the sentence knowing what's what. So the distance from the bottom of the ladder to the house, the orange, is 7 feet less than the blue, right? Less than from the top of the ladder to the ground. So what I need an X. We're going to do algebra. We're going to looking for something. So something needs to be X. So you have the choice. I know students don't like to have choice often, but you have the choice where to put the X, the blue or the orange. I'm going to just put you can figure out which one to put for X, like by reading what you're looking for. But let's just not worry about it. Just randomly put X to be the blue, all right? So if this is X, how long would be the orange? So going back and reading the problem, says the distance from the bottom of the ladder to the house, which is the orange, is 7 less than the blue. So this would be, oh, let's make it orange. This would be X minus 7, right? Right. Okay. So the question is, now let's see what we're looking for. How far is the bottom of the ladder from the house? We're looking for the orange, all right? The question is, technically, what's X minus 7? This question, or in order to find what's X minus 7, you need to find what's X. So technically, we're looking for X, all right? So here, we could have put X to be the orange and the other one would have been X plus 7. Hold on, let's make it get right. The distance from the bottom of the ladder to the house is 7 feet less than the distance from the top to the ground. Okay, that's it, right? So we could have put orange to be X and the other one would have been X plus 7 then, right? To the top of the, I hope we got it right. Distance from the top of the ladder to the ground, 7 less. Okay. So how we're going to do this? Let's use the Pythagorean theorem. Here we go. You know what? I like the thicker marker. Let's try. What was the Pythagorean theorem saying? A square plus b square equals c square. So what is our c square? The c square is 13 because it's right. This is the right angle, right? So the side across the right angle, oops, it's right here. So I'm going to have here 13 squared on this side, right? So the legs are going to be x, let's use their colors. X minus 7 squared plus, because it says plus right here, right? Plus x squared. We're going to make it blue. Not x squared, yeah, x squared, x squared. So now here you go, quadratic equation. Why is quadratic? Because x is squared. So how we're going to find it? First, you need to distribute to get the x out of the jail right here, right? And then we're going to set the whole equation to equal 0. So let's get going. So now we're going to use red. Let's do black. Okay, here we go. I guess we'll make it thin again. Okay, let's do black. So you need to, okay, if you know the formula for what is x minus 7 squared, you can write directly the answer. But since you probably don't, you have to multiply this by itself or just FOIL it, how some students like to say. A good thing, this we know what this is, square root of, 13 squared is 169. Okay, distribute, let's get the yellow, distribute, oops. Again, at this point, in math, if you're in this class, I should not tell you how to solve it from here. But in case I need a little refreshment, here you go. Speaking about refreshments, feel free to go grab a refreshment at this point. I had Coca-Cola earlier because me and Carissa, this is our thing. We always drink some unhealthy soft drink like Coca-Cola or Pepsi. She likes Pepsi more than Coca-Cola. Okay, so distributing x squared minus 7x minus 7x plus 49 plus x squared equals 169. Yeah. Next thing, you need to combine like terms, right? So let's combine the like terms. Who is who? This and this are the same. This and these are the same. And those are the same type of numbers. You combine them. Okay, so what we're going to get is 2x squared, okay, minus 14x plus 49. Let's leave it, let's do it in steps. So now next step, you want to set it equal to 0, if you remember, right? So you're going to get minus 14x. So when you subtract 49 from 169, you're going to get negative 120 equals 0. Okay. Now we have to factor this. You might be tempted to use the quadratic formula because there is 2 instead of 1 there, but notice something, they're all even numbers, 2, 14, 120. This means they divide by 2. So you can actually factor out what? That's right, greatest common factor. And when we did this earlier, Carissa actually knew what the greatest common factor is, and it was 2. Okay, let's actually do, this green right here. So 2 x squared minus 7x minus 60 equals 0. Since you have 0 on the right hand side, you can actually divide by the common factor and get rid of it. Pretty nice, okay. So they would cancel, right? And this is still 0. So what we have left, we're going to write it right here, is, now I feel we need a thicker, let's get darker. We have x squared minus 7x minus 60 equals 0. Okay, here, quadratic formula or factoring. The factoring could be easy because there is the coefficient in front of x squared is 1. So how we do this? The question, which two numbers multiplied, okay, would give you negative 60. And when you add them together, you're going to get negative 7. So it's like, let's see. Okay, go back to the, let's say blue. Okay, we do a little, oh, look right here on the side, we can do this. Okay. So 60, I need to get negative 60. Oh, okay, so we need to do this. Undo. Okay, let's do negative 60. Okay, so negative 60 is our goal. Okay, what makes 60? Let's ignore the negative for a second. 2 times 30. Well, if you subtract those, you don't get 7. Okay, 3 times 20. When you subtract 3 and 20, you don't get 7. 4 times 15. When you subtract them, you don't get 7. 5 times what? 5 times 12. Oh, look. If you subtract 5 and 12, you're going to get 7. So, these are the numbers. Which one is the positive? Which one is negative? The one which is negative would be the larger number because we have negative right here for the 7. So the negative would be 12. Okay, so going down here, let's fill our factoring form. Plus 5 minus 12. Okay, almost there. Now, how do you solve quadratic equation from here? You're using the property of zero product, which is x plus 5 equals 0, or which is x equals negative 5, or here we go, x minus 12 equals 0, or x equals 12. Okay, well, which one is now the length of this x? Well, it's a length, right? So the length is a positive number. You don't have negative lengths in houses. So this means that you can x the negative. It's not the solution. And what we're left with is the 12. So this means that the blue length equals 12. This equals 12 right here. Ooh. I don't know how to squish it. It's right here. X equals 12. Okay. Let's go back and see what are we looking for. We're looking for how far is the bottom of the ladder from the house. We're looking for the orange. The orange is x minus 7. So to find x minus 7, substitute the 12. So it's going to be 12 minus 7, which is 5. So our answer to this problem is 5. And I really hope we got it right. Okay. Again, I'm speaking fast, but you are free to stop and go back and rewind and listen again and again. Okay, I think this would, yes, okay. So, okay, so let's see. Okay, so this is how they're solving, explaining. So look at the picture. It's like, why? Why do you need all this detail? If you wonder why, it's because they want to confuse you, so you don't know how to do this problem. But if you look closely, let's get the red. Let's get the thick one. Oh, let's thicker. See, this is the ladder. Oh, what did they do? Come on, it should be that. And red and draw. Here is the, oh, look at this. This is the ladder. This is the distance to the bottom of the house, and this is the height. It doesn't look like this on the picture. This house is floating in the air. What is the yellow fire? Oh, I don't know why it's so complicated, but this is the problem. Okay, let's undo it. Moving on. Here you go, the equation, translate, to this. Okay, we did through those steps, common factor, get rid of the common factor. They should have got rid of it faster, but it's okay. They'll get rid of it here. Okay. Actually, don't have to get rid of the 2 because obviously the only way for this to equal 0 is if this equals 0 or this equals 0. The 2 doesn't play any role because 2 is 2. Okay. Check your answer and you are going to get 12. Oops. Okay. What we're going to do is one more problem right here. The problem I'm going to do is from the book, and I'm going to try variety. There is not much variety, but something. Let's see. Oops. let's find something with the Pythagorean theorem, okay, which is not exactly the same like with the house. Okay. Well, let's find it's on page, okay, it's in the book, so page, oopsie. Oh, why? I don't want to do anything. Oh, come on, let's do it. We're going to trick them again. Let's get the final thing. So let's now go. Go. I want the black screen. Okay, so here we go. It's page 395. And this is going to be problem 25. Okay, here we go. So you need to read it in the book because I don't have it here. I'll try to read it. Okay, so it says the leg of one. Okay, start over. It says the length of one leg of a right triangle is 8 feet. The length of the hypotenuse is 2 feet longer than the other leg. Find the length of the hypotenuse and the other leg. So let's start over. Apparently we're talking about triangle. Here is our triangle. I'll do it the other direction so it's a little different. And we're talking about the right triangle because there is the word hypotenuse. So here you go. This is the right angle. So which one is the hypotenuse? Right, this one. Okay, you know which one is the hypotenuse. So let's see what they're saying. The length of one of the legs is 8. So I'm picking one of the legs is going to be 8. Should we do blue? I guess let's do blue. So this leg is 8. I don't care which one is one of the legs. So I'm just saying 8. So then the length of the hypotenuse, which is this thing here, is 2 feet longer than the other leg. So so the other leg. We don't know what the other leg is. So something needs to be x. So let's put the other legs to be x. All right, so this is x. Then the length of the hypotenuse is 2 feet longer than the other leg. So the hypotenuse is going to be x plus 2. So my picture is definitely not very good one, but it does not matter, you know. All it matters is you got like the 8x and x plus 2 at the right spot, at the right side. Okay. Whew. So what we're looking for says find the length of the hypotenuse and the other leg. To find the length of the hypotenuse and the other leg, you need to find x. So x equals question mark. Ta-da! So from here, you can pause the video and try to do it yourselves because I know you can. So make sure you pause the video and do it. Okay. Okay, now since you already did it, let's see if you got it right. Let's do yellow. This is so much fun on the black background. I wonder if the whiteboard can be a black one. But it's called a whiteboard, so probably not. Okay. What we're doing, okay, writing Pythagorean theorem, x squared. Oh, no. What happened? Ay. The computer froze. Okay, so we have 8 squared. No. Why? Hold on. Okay, here, draw. I want to draw. Can I draw with the, oh, okay, draw with my finger. Is my pen die? No way, this pen cannot die. Okay, well, okay, let's do, okay. Okay, so we get x squared, I'm writing with my finger now, plus 8 squared equals x plus 2 squared, right? Okay, so what we do, we need to distribute, and I know you did it already, so I'm just going to use the formula, which is x squared plus 4 times x plus 4, right? So look at this. Actually, your x squared is going to cancel, which makes your life way easier. See? Because if you subtract it on both sides, it's going to disappear, right? Okay, so let's move on then. Yeah, so we're going to have 8 squared is 64, so 64 would equal 4x plus 4. Wow, this is super nice. We just have a simple linear equation. So this is 60 equals 4x, so x equals oops, got too excited, equals 15. Okay, x is 15. There are no other choices, just 15. So if this is 15, but then what does this make the hypotenuse? Yep, you're right, 17. Whew. So these are the only two types of problems we're going to do in chapter, what chapter is that? Chapter 5.9. And next week we're going to do review, and Thursday is going to be the test chapter 5. So let's get out of here somehow. Okay. So I'm getting out of this PowerPoint in a second. Ah, it froze. It's weird. It's freezing. But okay, it froze. So what I wanted to say, I wanted to show you that where is the link for MATLAB? And I showed you before and I say it again and I wrote it, but I want to do it again. So I guess let's do a new share. Stop sharing. Let's share the screen only. Screen again. And come on, I thought I'm out of this background. Okay, so we're going to close this PowerPoint and let's look at introductory algebra. Look at that. See? Okay, so here is the link. We had it before right here, you know, the MATLAB. I'm usually using the link for the MATLAB, which is located right under syllabus. The link is right here. See the link? Oops, let's see if my pen would work now or it was totally something else. So it works. Okay, I hope it works. Here we go, MATLAB. Yay! See the link? If you click on it, you get the Zoom. But this is the college's account, which if it's in use, like right now today was in use when I was recording. So if this is in use, I'm going to post another link and say, hey, the link has changed. Like it happened a few days ago. It says, where is it? It says, oh, the link for Zoom today has changed right here. Right where? No, we don't want this. Hold on, go away. We don't want to open another Zoom. Okay. But if you don't see this message, then this means that you need to go to here, click on the MATLAB and join for Zoom. That's for today. Tomorrow is MATLAB. Feel free to join. So let's see how we can stop the recording. Okay. Bye.